Hello everyone, welcome back. We're now on part 2 of our advanced GIS methods training focusing on retail centres and catchment areas. So again, we've got Dr. Les DeLiga from Department of Geography and Planning, University of Liverpool. And we're also joined by Patrick Valentine, who's a PhD student in Geography and Planning at the University of Liverpool. So I think Les is going to kick off with our presentation. So I'll hand over to you, Les.
Thank you, Nick. Right, so welcome to part 2 of our presentations, our training. So in this part, I'm going to talk about retail catchments. So effectively, we are going to answer a second research question, which is who uses the retail centers? So in part 1, we've answered the question, where are the retail centers? Now we are really interested in who is using them. So I'm going to cover here different definitions of retail catchments, explain what retail catchments are. I'm going to talk about different delineation techniques and a little bit of applications in the real world of those retail catchments. So first of all, what is a retail catchment? So retail catchment is typically defined as an area from which retail centers derive most of its patronage. In other words, it's where the customers are coming from to a particular retail centers. So you probably also will come across different terminology in relation to retail catchments. Something like primary catchments, secondary catchments is often referred to in the literature and reports, scientific reports. So typically, there is no kind of strict definitions of those, but by primary catchment, we understand those areas where the most of the patronage is drawn from. So the most of consumers are coming from. So at least 50% and over, in other words. Or if you look at simple drive times, that would be your near kind of store catchments, which is 5 to maximum 10 minutes drive time from your location, from your house. In terms of the secondary catchments, that typically that would be the further 25–30%. So of patronage, so anything, I'm going to talk about this later on, so anything between 25% to 50%, and that will be an equivalent of around, on average, 10 to 20 minutes drive time. We also have, occasionally we use tertiary catchments. Pretty much all retail catchments, they will overlap. That is strictly related to consumer behavior. We are complex beings, so we hardly ever think in terms, yes, I will be shopping only in one retail center. So we normally shop in many different retail centers. So so there would be a proportion of people who in each location that will shop in particular, catchments as a tertiary option, basically. So it's further 10–15% of patronage, and typically that will be 20+ minutes drive time. So you live quite far away from the center, but you still consider coming from time to time to the retail center. And for this reason, that would be called your tertiary catchment. So in here, we've got two different types of catchments, two different maps. The top map here shows you the spatial interaction models catchment for Birmingham area. By the kind of darker shades, you have the primary catchment, so 50%+. And lighter shade, as you can see here, is the much larger extents. That would be the secondary catchment, so anything between 25 to 50% of patronage. And here on the bottom map, we have just a simple kind of catchments of 5–10 kilometers drive time or bufferings. So in terms of the actual delineation of retail catchments, there are a number of techniques. So you could simply argue that most of the retailers, they should be able to map the customers' locations, domiciles, and that is correct. So if they have loyalty cards and they collect data on consumers, they are mapping the data, and effectively they can see where the customers are coming from. And that is very good and very, very useful. However, they may also need to to see where they're underperforming. Maybe there is a stronger competitor somewhere else, and they will use different modeling to estimate where the catchment, what could be the potential extent of a catchment. In this training, we are working with retail centers rather than retail stores. So for retail centers, we won't have such consumer data. So we will use pretty much modeling only. So we talk here about simple and complex models. There is kind of broad division into two different types of modeling retail catchments, or pretty much any catchments. This could be applied also to schools, train stations, and so on and so on. So in terms of the actual simple methods, simple techniques, we have three different techniques here. So we've got buffers, which is just a circular distance, straight line distance from a center. Here we've got Liverpool city center, and you've got 5, 10, 15 kilometers or 5, 10, 15 minutes drive time. Then you've got drive distances. This is also a distance, but it's the more kind of probable distance, if you like. So, but what it means is it's more, it accounts for, it uses road networks and accounts for all the geographical barriers rather than just looking at a straight line distance. So for example, you've got Irish Sea here, obviously Mersey River. As you can see, none of the drive distances, drive times include the area because no one lives there. Whereas buffers, they just include anything, what's in there. There are clear advantages of using these simple methods. So for example, these techniques are very easy to compute them. They're still very useful. They are used by a range of retailers, especially if they want to find the best location, let's say, for a small convenience store. Drive distances, drive times, it's a very popular technique. It's easy to derive, and you can get really quick estimates in there. And typically you use free data, which is very useful, especially for researchers, I suppose. But there are also clear limitations of using that method. So basically using these simple techniques, we do not account for competition very well. We pretty much, if you look at this map, we assume that everyone living in those areas will shop in Liverpool city center, which obviously is not the case, because if you live in the Wirral, you're very likely to shop in Birkenhead. If you live in St. Helens area, you're very likely to shop in St. Helens, and so on and so on. Also, the complexity of consumer behavior, the sort of attractiveness concept, which we talked before about, is not captured pretty much at all in here. Right, so for these reasons, we use something called spatial interaction models, SIMs, in other words. Typically, these SIMs would be also called gravity models or probabilistic models. And they apply the Newtonian law of physics, gravity, basically. So that's the very simple concept of it, where patronage depends on town center attractiveness, but declines with distance. Okay, so in other words, the more attractive retail center is, the larger area is going to drive customers from. And that attractiveness declines with a distance. So if you live not too far from the retail centers, you are much more likely to visit that place, the retail center, as opposed to if that retail center is really far away. So you're gonna visit it only from time to time, most likely. These kind of spatial interaction models, complex techniques, are much more accurate. They account for the hierarchy of the retail centers, which we talked about in part 1. However, on a kind of negative side, we have a couple of things listed here, limitations. We need validation estimation of parameters. There are a number of parameters which I'm going to introduce in a minute, and they have to be estimated, and the results have to be validated as well. As without estimation and validation, we can just use arbitrary ones, but we won't. That would be prone to kind of errors, larger or smaller errors, and the limited access to consumer insight data is something which is kind of difficult for a number of researchers. So you have to either apply through, let's say, CDRC for some of the data which you have, or directly with the retailers. But this is sensitive data, so many retailers, they are not really willing to share that with researchers. So in here we have the actual output of that Huff model, where we calculate the probabilistic patronage based on a number of things. Okay, typically this is based on attractiveness of retail center, the hierarchy. We also account for the hierarchy, the distance between consumer domicile and the actual retail center, and competition. All these factors are included in the model and accounted for. And so what we effectively create is the probabilistic surface that accounts for competing shopping destination. And again, here we have the Greater Manchester, right? And we have the Huff catchments for Greater Manchester highlighted. We have for the entire England here, but you know, the Greater Manchester is highlighted. So you can see that Manchester city centre has the largest primary catchment, which is in red. Okay, and then each of these satellite towns, they have smaller, but they still have, you know, sensibly large retail catchments. Then in orange, you have the secondary. So it's pretty much it's shared. Let's say people living here, population typically will share. You choose either, let's say, Bury or Manchester. Okay, so that's why it's less than 50%. And then you've got the tertiary catchment in this kind of beige, light orange color, which covers the entire Greater Manchester and goes beyond. Right. So let's have a quick look at the actual Huff model, because you are going to use that in the practical exercise. So this is the formula for the model. Let me explain it to you. So what we calculate here is we calculate the Huff probability, P. P of which is probability that a person living in a particular location, in our case, we look at LSOAs, okay, will shop at the place J, retail center in our case. And that probability is a function of the actual attractiveness of our retail center, J, okay, and a distance between where the customer lives, LSOA in our case, customer I, and retail center J. That can be subdivided further into hierarchies like large, medium, small centers and so on. And then we've got a couple of parameters which we need to estimate. We've got alpha parameter, which is a attractiveness enhancement parameter, and we've got beta parameter as well, which is a distance decay parameter. So the distance decay parameter is the most important parameter. It's an exponent, pretty much. So it's an exponential decay of the attractiveness depending on the distance. So the further retail center is, there is an exponential decay in the actual attractiveness of that center. And by using alpha parameter, we account for the sort of non-linear consumer behavior. So so we can increase or decrease the actual attractiveness in that model, depending on consumer perception. So for example, if someone is living very close to that and likes convenience by walking to retail center, obviously that attractiveness will increase to those people. Or if someone is very particular or very limited by opening hours as well, and so on and so on. So the default value here is just 1, and then we can increase or decrease. So as I already mentioned, these parameters, they need to be estimated. So for stores, retail stores, typically they are estimated by employing either household surveys or loyalty card data. If we have such data, then we employ statistical modeling, such as regression analysis, and then obtain the parameters for every single retail center or retail store. And that is the proper way of doing it. However, if we deal with retail centers, we don't have such data. We don't have loyalty cards for the entire retail centers. It is not that easy to estimate retail sales for the entire retail centers either. So the parameters will be typically based on literature, and they will implement the retail hierarchy, and they will be also validated by some sort of surveys. So for example, we have this Axiom survey, which we used here in our research, and we tweak the parameters based on the actual surveys, which is not ideal, but but if you have the data, if you work for a commercial consultancy, you will have probably access to different type of data, and you'll be able to use the statistical modeling to estimate the parameters. So in terms of the actual displaying and mapping of Huff catchments, what's really important in here is to understand that each LSOA in our practical exercise will have a range of Huff probabilities assigned to them. So in our case, in Liverpool City region, we work with 20 retail centers, 20 most attractive retail centers. So in theory, each of these LSOAs will have 20 different Huff probabilities assigned to them. That will vary from 0 to 1, with 0, no patronage, 100, that's the only retail centers that a customer will shop in, which probably is very unlikely. Typically, that would be a range in between somewhere. Normally, it's not 0, it's not 1 either. And what we do, so having 20 probabilities for each LSOA would be difficult to visualize in terms of the actual catchment. So what we do, we only display the highest probability for each LSOA. So we select the highest probability for each LSOA, and then we apply different thresholds, which are in fact, in a way, they are arbitrary. But we want to display primary, secondary, and tertiary catchment. So typically, if you display 50% or over 50% or plus, then you will have the primary catchments. If you display anything between 25 and 50% annual value, you will have secondary catchments, and then obviously below 25% or below 20% will be your tertiary catchments. So that were the models and retail catchments estimation. Now, let's have a quick look at different applications of that. So having those two questions, research questions answered, where retail centers are and who's shopping them, that gives you, if you're a retailer or town center planner or town center manager, that gives you a very, very important kind of information, right? Very useful information, in fact. So there are a number of retail consultancies, even a government, they like to collect retail center statistics and compare them against space and time. So you can see how the particular center, what is the trajectory of particular center, particular region, how does it compare Northwest to East Anglia, and so on and so on. This is, of course, very important for retail planning and management of retail centers. And if there are some interventions, let's say like Porter's pilots or something like that in the past we had. So by using these retail centers, you kind of have more informed debates and more informed decisions. Retailers, on the other hand, they will be very interested in creating something called catchment profiles. So once they know what is the kind of retail catchment, they will look at the demographics of that catchment. So they will look, what is the total population, what is the affluence, what is the average age, sex, consumer behavior, online shopping prevalence, and so on and so on. They will compare this against other stores, national average, whatever, and they will create something called a retail catchment profile, which is a very, very useful and powerful tool for retailers. In research, for example, in academia, we work with that as well, and we use that retail catchments and retail centers to create something we call multidimensional typology of shopping and consumption spaces, retail centers, in other words. So rather than looking at the hierarchies from high to low, we look at centers in a different way. We compare the characteristics in a number of different domains by looking at different domains. So we can also compare them against, different centers, different areas, and different time performance. Okay, so that's it. And there is a research paper here which talks about the multidimensional typology. Thank you.
Great, thank you very much, Les. Yeah, that was really interesting. So there's lots of things to consider there, but it's great to see how it all kind of comes together. In the practical element, we get you to map some of the different Huff probabilities, and we get you to run the model as well. Patrick, I was wondering if you could say a little bit about the different thresholds that we use in the practical, because there's a more than 40% and then a more than 60%. So do these map to the primary and secondary catchment areas, as we heard, and why did you pick those particular thresholds?
Yeah, exactly. Yeah, no problem. So as Les said, it's the whole process is all about modeling consumer patronage from an LSOA to a retail center. And in essence, if you were to pull out everything, you would end up with, in our case, you'd end up with a proportion for 20 retail centres for every LSOA, which isn't ideal when you're trying to build up kind of the main picture of an area, and also make maps and make nice maps and things. So what we want to do in this practical is look at kind of the top picture or the kind of primary catchments for each retail centre. So as Les said in the presentation, kind of a typical figure we would use would be over 50% patronage. But in this case, what we thought would be good to do would be to show kind of an above and a below, just to kind of so that you can compare. So in this case, we use 60 and 40. What people who use the practical and run that will notice is that obviously, if you run with the 40% probabilities, you're going to end up with much larger catchments. And then if you run it with a 60% probability, the catchment will be much smaller and condensed to a kind of more local kind of LSOA pattern. But yeah, it's in essence, it's just to kind of make it less apparent, because obviously there's a huge overlap when you pull out the catchments for the whole catchment for a retail centre. So it's all about trying to just get that kind of key primary kind of picture. But obviously there's a lot of freedom in that practical to do as you wish, as you want. If you wanted to potentially look at the way that we've showed you how to use case when and mutate, you could go in and actually integrate building a primary, a secondary and a tertiary catchment out of that yourself. So there's a lot of flexibility but it's just to basically just kind of give you an overall picture and to make it a bit easier to understand.
Okay, great. Thank you very much, Patrick. It's good, and it's we've got the opportunity to try the different probabilities and see what the maths create. So do experiment with those when you do the practical and see what the outcomes are. Kind of on that note, and building from that, how much of this is exploratory data analysis in terms of trying different factors and seeing what works, and how important is local knowledge to work in a particular area? Yeah,
I suppose there's a certain element of local knowledge that's very important to this. Myself and Les, we're both residents of Liverpool, and we know roughly kind of in our heads what a catchment should look like for that area. So that there's a certain element of that is local knowledge, but when we're doing things like this and we're trying to build catchments that work and are kind of feasible and make sense for policy and things, you've got to focus really on the data itself and the approach that you're using. So typically what we would do is we'd build out the catchments using the model, probably extract the primary catchments, but then, as Les said in his presentation, would go through and perform some sort of verification of those catchments to ensure that what we're getting in that exploratory nature is actually making sense in the way that actually the data works. So Les said that in their paper they use Axiom data, a survey, to do so. There's lots of other ways. You could use loyalty card data. One thing I'm using a lot in my research at the moment is mobility data. So I'm building out a set of retail centre catchments for the US at the moment. And what we're doing is using kind of GPS data of where people live and where they go to work out kind of the maximum distances, but also the probabilities that people might commute from a certain part of, say, New Jersey to Manhattan to shop. So I mean, there's a fine balance, but I would say in with this and with this application, the focus is really on the data and exploring it and then verifying it.
Okay, wonderful. Well, thanks very much for that, Patrick. No, it's great to get your kind of insight on that. Thank you very much both for the presentation. It's really good to see. Do have a go at the practical, do experiment with the code as well. We've given you the R code as well, so try different things. So do let us know how you get on.